Hi guys, today we are going to define about a line which is inclined to both the planes. In the last videos, we defined a line in a different orientation, in the sense which is parallel to a plane, perpendicular to the plane, inclined to any one of the plane. But present, we are going to define a line which is inclined to both the planes, which is also known as oblique plane. Now, we are going to have a very basic information which really matters to solve of any kind of a problem in the projection of lines. So let me start the projections of a line which is inclined to both the planes with a few consideration, which means that so we have a true length and we need to determine the final front view and the final top view of the given true length. So let me have a plane with a reference line xy, and as this says that we are in the first angle projection, so the front view will be above the xy and the top view will be below the xy. So now we are going to get the projections of a point A, so which is above the HP and in front of VP. So with the help of these things, so we are going to define the true length with a few angle, which means that so now the A dash B1 dash was a true length of a line and it is inclined with respect to HP, let us say angle theta. Similarly, in the top view, it has been notated as AB2, which is a true length, which has been inclined with respect to VP and it has been notated as an angle pi. Now we need to get the locus at the B1 dash as well as at the B2. The locus should be parallel to the XY. The reason behind this is when we made a line inclined with respect to HP or with respect to VP, it has to be satisfied at the both the ends. In the sense, it has to be satisfied the angle with respect to A as well as with respect to B. There's a reason why we need to draw a locus line. That too, it should be parallel to the XY. In the sense, whatever the angle we have done with respect to A, the same thing will happen with respect to B also. So, and moreover, we can name the locus line in the front view as an FF and the locus line at the top view as a TT. And now we are going to get the projectors of a point B. So let me have a projector from the B2, which is from the top view. And now it has been notated as a B2 dash, and the projector, it has to be in terms of a straight line. So as the A dash B2 dash was a straight line, which says that as we got the true length in the top view, then the projection of the true length in the front view, which is notated as a dash B2 dash, it ought to be in terms of a straight line, and it was in a false because we observed an angle in the top view. That's the reason we defined it as a true length. When we view in the front view where we can't define the angle, so we need to place it as a false, and it has to be in terms of a straight line. And we don't have any more scope to place the B2 dash over this particular manner because B1 dash, which has been inclined with respect to HP, so it has been placed in a new position, and we have drawn a locus line which says that which is a source for the front view B points. So wherever we get the front view B projections, then definitely it has to be placed only on this particular line because it acts as a sources for the front view B projections. So we can't place the B2 dash as a straight line. Now we need to place the B2 dash in terms of the locus line itself. So A dash as a center, A dash B2 dash as a radius. We need to draw an arc until it intersects towards the locus and it has been placed as a B dash. So finally, when we start joining the B dash to the A dash, so it has been represented as the final front view. Now we are going to draw a projector from the B dash until it intersects towards the top view locus line, which says that the projector was a straight line which ought to be connected the projection of a B. In the sense, it has to connect the front view projection of a B as well as the top view projection of a B. So when we start drawing the projector from the B1 dash, it has to be project on the top view and it made in terms of the straight line. In the sense, the AB1 as a straight line, which says that as we got the true length in the front view in terms of an incline, then definitely the projection of the front view in the top view, it has to be in terms of a straight line and it should be in terms of the false length itself. And moreover, we don't have any sources to place the top view B1 point over this particular line because where the B2 which says it was the the top view B point which has been inclined with respect to VP, and we have drawn a locus. So wherever we need to place the top view B point, it has to place only on this particular locus line, which says it was a source for the top view B projections. So now the A as a center, A B1 as a radius, we need to draw an arc until it intersects towards a particular locus line, but not only the locus, and moreover it has to intersect towards the projector, which start drawing from the projection of an B dash until it intersects towards the top view projection. In the sense, so finally the B, it has to connect the projector as well as the locus of the top view B projection. If we start joining from B to the A, so it has been represented as a final top view. And now we are going to represent an angle for the final top view as well as for the final front view. So the beta and the alpha are called as an apparent angle. It should be greater than the theta and the pi. In the sense, the theta should be very less compared to the alpha, as well as the pi should be very less compared to the beta, where the theta and the pi are the true inclinations of an object. So finally, we get a true length in the front view, then the projection of the front view in the top view, it need to make in terms of a straight line, which is a false length. And as we don't have any more sources to place the top view as in a straight line, so we need to place on the locus of a top view projections. A, B says it was the final top view. Similarly, as we get the true length in the top view, then the projection of a true length top view in the front view, it has to get as a straight line, which is nothing but the false length. As we don't have any more sources to place the front view projections on a straight manner, so we need to project on the locus of the front view projection B points, connecting the A dash B dash, which says it was the final front view. So now we are going to have a few considerations. With these considerations, we can define any of a problem in the projection of lines. The considerations are the final front view and the final top view, where both are false length. And next one, if we need to get a true length of any of a projection, then definitely whatever the false length we have, for example in the final front view, the false length, it has to get in terms of a straight, and as we got in a straight in a one projection, then the projection of the next view where we get a true length. Similarly, if we need to get the true length in the front view, then the false length of a top view, it has to get in terms of a straight. So as we get it as a straight, then the projection in the front view where we get it was in a true length. So this was the second consideration, and the final consideration was the projectors of a particular projection of a respective point, it ought to be in terms of a straight line. Thank you.